Welcome to myprojectbuzzer.com. Let us see the title of the project: Effective Content-Based Video Retrieval Using Pattern Indexing and Matching Techniques. The stack of the title: it's a content-based video retrieval even to the two kind of the visual features of considering. We have using the AFA, Advanced Frequency Pattern Indexing. It's a really efficient method for finding the deserved video from the massive amount of the diverse data. The data retrieved from the frames. The frames we constitute to the video frames. We have first of all we setting to the frames for all the devices. The two methods we have mainly used. One of is index based, another is searching based. Indexing based we have the PI models. We have retrieving the information for the video frames and retrieving the similarity tree basis. The frequent pattern indexing we have a familiar technique to use to the indexing model. Then advanced frequency patterns we have checking to the frame basis. Normally we get into the input of the frame and getting the output of the frames. Now we have checking to the group of input for 5 images or the clipping images. The clipping images we have the massive moment of diverse part of the videos will be recognition. The frames will be diversion, then the distance will be diversion, then will be formation for the frequency pattern tree. For example, if a frequency of the clipping trees we searching to the index and searching model, the clipping each and everything we have checking to the relation. The frequency panel we have checking the distance basis. This distance basis 0 basis we have the matching the result. Then the 0 amounts to the nearby similarity for the images the frames as we getting the result of the frames for the tree basis. So the tree basis of images retrieved from the video frames. So the input is the video frames. The frames will be converted for the saving to the databases file. So the databases wise frames we have checking the AFA and FBI basis. The result will be analysis for the tree formations for the order wise. So 0 is the topmost result for the extract matching. Then similarity images will be distance calculated for the step-by-step procedures. It will be used to the content-based video retrieval. We have using the frames for the precisions. So the total number of records we have and the frames steps and the frame size evaluations will be calculated. The short exception that the accepted extrusional range will be calculated for the automatically processed to the massive. Let us see the flow of the diagram. So the flow chart is the query images. We have the query images, we have the clip images we including. So 5 images only for uploading to the clip images. The set of the 5 images including that the image query. So the image query short detections we have mentioned to the 2 type. So the feature selection, the color edge detections. The 2 type we have mentioned to the short detection. The short detection will be clustering formation. In the clustering formation we have the sorting to the AFI, frequent pattern and advanced frequent pattern indexing. These indexing models we have encoding the glyphs. The encoding glyphs we have sorting to the encoding glyphs result. So the querying of the clipping we have checking to the sort detection and the derivation to clustering. Then the clustering models we have using to them FBI and AFA model. The AFA model we have the encoding the clips. The clips will be sharing to the content of the result. Let us see the demo of the process. The video data and pre-processing data result analysis. The video file is checking to the file and clicking to the frame open. The frame will be sharing for the video and the frame result. The saving done. Then clicking to the frame video successfully added. Clicking to the another frame. So the video will be loaded. The frame of the image will be done, saved done. The video frame video successfully storage. This is the video frame and video settings for the pre-processing. The video data will be collecting for the databases. So next we have the pre-processing step. Pre-processing step we have needed to the query clips. So we including the query clips for image folder. So the image folder contain the 6 images. So the 6 images we have the query clippings. So only for 6 images content to the query clips. First of all checking to the short detection. The short detections for using the query clips. Next is short expression. Clicking to the short detection for the user input to query clips. I will clicking to the this short detection frames. The short expression I will clicking that future extraction. The feature extraction, we have mentioned that the C color edge detection and the fuzzy color edge detections model. The CCED mentioned for the color edge detection derivation. Click the total number of derivations. I give the 100 images. Clicking the feature extractions, still to wait for loading process for the 100 images to the query glyph will be processing this level. The extraction result will be show that the file transfer for the resulting for future extraction for the distance spaces features. Then we have the start clustering. The total data is the thousands. The extraction result for 4950 result will be in the databases. The short clustering for the clustering based using to the short animation. So 0 is the matching result for the content. The next is the order basis we have excluding. The LUP value will be distance for the average for the means value will be display. Next we are going to the indexing stage. Index stage change. The pattern generation. The pattern generation, click that. The pattern generation for the sorting clustering values will be displayed. The query glyphs, number of glyphs 6 and the ratio is 2 and the event size is 6. So the formula, I will click the FP tree basis 0, 0 and 1, 1, 1 result of the similar is distance for the frequent pattern distance. I am checking to the decimal pattern and the entire 0, 0 and 1 result will be sorting for the average meeting. Average beacon patterns to extract the hiding information, also retrieve from the extract result for the advanced beacon pattern. The frequent patterns only display for the 0 extract match only for the beacon pattern, but the advanced beacon pattern the extract result and similar matching for the next frames similar matches we have information getting to the result basis. So this information clustering type will be evaluation for the pattern and matching techniques we are using. So FBA and order basis and the AFP order basis. The data video recording will be the analysis the result of that. So the video and the video ID of the path. Click the data frames. We have the pathing data for the clustering data path will be checking for the order basis, and the frame images and the frame path will be displayed, and the details of the display for the recognition for the result analysis, the data resulted. So 7 videos we have contributed and the 1113 frames will be also. So just view that the frames and extend the frames and path will be order basis. So frequency of the clipping result and the result will be generated for the videos and the frame result. So the frame result or the matching result for the frequency pattern and advanced frequency pattern indexing. So indexing model will be retrieve the videos and the frames for the extract result to that one. So the result will be order for the tree basis. The previously we have explained to that. So this is the result of the videos. We will retrieve the information from the databases. So after the frequency pattern data, the result will be the matching and pattern techniques to retrieve the videos and the information for the frames. Thank you.